Okay, if you could please find your 6-6 notes on exponential and logarithmic equations. They are either in your note packet, or if you do not have your note packet, you can print them off of my Google Classroom. We are going to start today by solving exponential equations. There are multiple ways of solving these, but the first way I'm going to teach you is to try writing them so the bases are the same. The first example we are going to go over is letter C. If you notice in letter C, the bases are already the same. Once the bases are the same, because they are equal, then you note that the exponents also have to be equal. So in this case, I would set 2x plus 4 equal to 5x minus 8, and I would solve that equation. The first thing I would do would be to subtract 2x from both sides. Then I'm left with 4 equals 3x minus 8. Next, I would add 8 to both sides. Then I am left with 12 equals 3x, and my final step would be to divide by 3. So my final answer would be x equals 4. It's pretty easy when the bases are the same. It is a little bit harder when the bases are not the same. If you look at example B, you will notice I have a base of 9 and a base of 27. If the bases are not the same, you must first look to see if you can write them with the same bases. 9 can be written as 3 squared, and then I still have my power of 8 minus x. 27 can be written as 3 to the third, and I still have my power of x minus 3. If you remember your properties of exponents, whenever you have a power and a power, you must multiply those. So I would multiply the 2 and the 8 and get 16, and then distribute the 2 and get minus 2x. On this side, I would distribute the 3 and get 3x minus 9. Once I have the same basis, I would then know that my powers also must be equal, and I would subtract 16 minus 2x and set that equal to 3x minus 9. And once I did that, I would just take and solve that equation for x. When you solve this equation for x, you get x equals 5. Let's try one more of those kind. If you look at letter D, you will notice the bases are 4 and 8. Even though the bases are not the same, they can be written as the same bases of 2. So 4 is really 2 squared to the power of 2x minus 1. 8 is 2 to the third to the power of x plus 2. Once I have the same bases, because these are both powers, I can multiply them. So I get 2 to the 4x minus 2. And on this side, I get 2 to the 3x plus 6. Once my bases are the same, I can then set my exponents equal to each other. So I take 4x minus 2 and set it equal to 3x plus 6. Once you solve this equation, you get x equal to 8. If you look at example 6.6be, now we have a little bit of a different situation. If you notice, the bases are still not the same. However, there is no way of writing 4 and 20 with same bases. If that is the case, then we learned a few sections ago that you must then do something so we can write them in a different way. What we can do is we can take the log of both sides, and as long as we do it to both sides, they are still equal. If you remember your properties of logs, you can then take the x and write it out front. And get x log 4 equals log 20. Then to solve and get x by itself, you would take and divide by log 4 on both sides. When you divide log 20 by log 4 on your calculator, you get 2.16, and that is your answer for x. F is the same way. You cannot get both 3 and 5 with the same base, so I'm going to log both sides. So I have log 3 to the power of x plus 3 equals log 5. Once I have that, I'm going to take the x plus 3 using my properties of logs and write that out front. So I have x plus 3 times log 3 equals log 5. I'm then going to divide by log 3 on both sides. So then I end up with x plus 3 equals, if you divide by log 5 by log 3 on your calculator, you get 1.46. Then if you subtract your 3, I get x equal to negative 1.54 as my final answer.